Welcome everybody to week 10, day 3. We're going to do 2 short lectures today, then do a lab time related to data science. So the first thing we're going to do is kind of go over vectors a little bit more. Some students have been asking questions about, I don't feel like I know everything you can do about vectors. And so I decided that not only are we going to talk about vectors today, but your next Xylabs will be kind of a review of the older topics as well. And we're going to do that for a couple of reasons. First of all, it'll help you deepen your knowledge of the topics we've gone over before. And second, if any of you guys copy the answers on these after being warned last time, it's instant death. So just be aware of that. So it's good for you, and it'll also, possibly kill you if you cheat. So don't. Okay, so let's talk about vectors. So a vector, so if we make a vector of integers named vec. We can even initialize it with some values, 10, 20, negative 10, 100, 200, 420. Every vector has a vector.begin, which is something pointing at the beginning of the vector, something called an iterator. And so you can actually save this into a variable if you want. Auto iterator equals this. And you can also save the ending iterator as well here, like that. And somebody's walking up on my house. I don't know who that is. And so we could sort a vector like this. We can sort from iterator 1 to iterator 2, like that. And if we do that, we can make a little print function here, void print, auto vec. This will work with any type of vector, not just vectors of integers, and it'll work with any type of container technically. You say for every auto x in vec, cout x and a new line. Okay, so we can print the vector like that, and then we can print it again after sorting it. Maybe we'll do a little cout, put a little divider there between it or something like that. Okay. So if we do this and run it, you'll see here is our original vector, and then after we sort it, it is sorted from least to greatest. So, and we did this by using vector.begin and vector.end. I just saved them into variables. You don't normally do it this way, right? Normally you would just say vector.begin, vector.end, but I just kind of wanted to show you that these things are variables. And you can even do things with the variables. For example, I could say it1 plus equals 2. And what this will do is it will move it1 from pointing at 10 to pointing at negative 10, right? Because I moved it 2 to the right. So instead of pointing there, it'll point 1 to the right, 2 to the right. Does that make sense? Maybe I shouldn't do 10 to negative 10. Maybe I'll move it 3 to the right. And it'll point at 100. Okay. Does that make sense? So it was pointing at 10 before, and then we move what it's pointing at 3 to the right by doing this. You guys have any questions about that? Let me draw this for you. All right. Maybe this would work better if the USB was plugged in. There we go. So if you've got a vector, there's a couple interesting things about a vector. The first is index 0 is vector.begin, right? And if we've got, what do we have in our array here? 10, 20, snap this over here. 10, 20, negative 10, 100, 200, and 420. What's interesting is that vector.end you would think, actually, what would you think? Nobody's said anything on chat in a while. What do you think vector.end is pointing at? So if vector.begin is pointing at element 10, which one reasonably makes sense for you to be pointing at if you are Mr. Vector.end? 420, exactly wrong. So vector.end actually points at 1 past the end of the vector. Okay. And another interesting fact about it is that there's actually a lot of unallocated space over here. And so there's actually probably more elements in the vector than we've seen. So vector.size is the difference of vector.end minus vector.begin. So index 0, 1, 2, 3, 4, 5, 6. So if you subtract 6 minus 0, you get 6. So there are 6 elements in the vector. So that's how it computes vector.size. It actually just differences the beginning and the end. I mean, if the beginning's always 0, then you just see out what, I guess you technically have to minus it to make it work. Anyway, so yeah, 6 minus 0 is 6, right? That's the size of the vector. There's also something called vector.capacity. And that is something we don't usually mess with very much. There's actually a third pointer. And there's actually like the, what do you call, like the real ending or something like that, like you're playing a light novel or something like that. And that's actually where the end of the array is, because the vector is really just an array that's made up to look fancy like. And so if you were to insert things into this vector, what happens is if you insert, another 10, another 20, another 30, another 40, eventually the thing runs out of capacity. And when that happens, and you try writing into it again, it will make a brand new vector twice as big as the one before, and it's going to copy over each one of those elements into the new vector. I made this way too big to... I'm probably going to run out of room in this vector too. We're going to copy all these elements over, and then the new one, I'm going to have to scroll to the right. The new vector is twice as big as the old one. Yay, there we go. And then you can continue writing into it and write new values into this one until that one fills up. Now you need to make a new vector twice as big, copy all the old ones over. That's how a vector grows. The thing actually does not grow one at a time. What happens is that it secretly, behind the scenes, has a unallocated, unused memory. When that gets filled up, then the whole thing reallocates. And when it does that, if you've saved begin and end into a variable, this is why we don't do it very often. Those variables are now no longer pointing at the right thing, because we've got a brand new vector over here, that has 10 and 20 and negative 10 in it. And these guys, which are pointing up here, they're wrong now. So we rarely save these things into variables like that, because you always want to just kind of, like, every time you do a push back into it, there's a possibility your begin and your end are invalidated. So we usually don't save them into variables for that reason. But it is a little bit helpful knowing that a vector behind the scenes is oftentimes over allocating memory. You can push things into it and it just writes things into the memory until it's full, and then it will double in size, copy everything over, and keep going. So so the end is actually pointing here. And the reason for that is because in computer science, we have what's called the half-open code pattern. So in algebra, you might have seen a range that looks like this. That means all the integers from 0 to 5, not counting 5. Have you guys seen this before? Square bracket means it includes the 0. The parentheses means that it does not include the 5. Okay. And this is exactly how we write code in C++. We will say for int I equals 0, I is less than 5, I plus plus. This is the half-open code pattern from algebra in computer science. This is the standard way we do ranges. Okay? Less than, right? Not including 5. And so this will do 5 numbers from 0 to 4. This pattern you see everywhere in computer science. That's why I teach you that pattern for doing for loops. It's the same thing for here. If you want to print out all the values in a vector using iterators, using iterators, you can do that. So we can say auto iterator for auto iterator 1 equals vector dot begin, as long as iterator 1 is not equal to vector dot end iterator 1 plus plus cout star iterator 1 and 1. So the star means print what is pointed at by the iterator. So vector.begin is pointing at this address in memory. If you actually want to get the 10, you have to say star vector.begin. So star vector.begin, if you just couted star vec.begin like that, that is exactly the same as saying vector.add0 or vector.front. It's 3 different ways of printing out the first element in the vector. Yep. 10, 10, 10. Why is it not? Because they're not comparable in that way. You just keep going until you hit the. You keep going until you hit this point. So it's going to go to the right, go to the right, go to the right, go to the right, until vector.begin reaches. So when you say plus plus, it moves to point to one element to the right. Plus plus, plus plus, plus plus, plus plus. And then once it hits here, then it is equal and you stop. You do not want to print out the value at vector.end because this value here is not valid. It's undefined behavior, maybe a crash, maybe not. Might throw an exception. You shouldn't do it. So, but yeah, good question. All right. And so then we can see here we've moved the iterator pointing at 10 to be pointing at 100, and then we're going to sort the numbers. Actually change them so they are actually going to be sorted. There. Okay. So this will sort them from 200, 120 to 20, 100, 200. So from 200, 120 to 20, 100, 200. So you can use these pairs of iterators. A pair of iterators like this is something called a range. And a lot of standard library functions take ranges as parameters. Usually we just say vec.begin, vec.end. We usually don't save it in a variable. Usually we just do the entire thing. We don't typically do something like that either. So let me just do this instead. Random shuffle from vector.begin to vector.end. Okay. And this is a deprecated function. It'll warn that it's deprecated. It'll still work. Nobody cares. And you can see here, here's my, actually let me get rid of that. We don't need you anymore. And these two are equivalent basically. Okay, so you can see here we had 10, 20, negative 10, and then it shuffled it. So if you want to shuffle all the elements in a vector, you can use random shuffle. It's deprecated. You're not supposed to use it anymore. There's a much better thing called shuffle, which if you pass in rand, does the exact same thing as random shuffle. It's just harder to remember. One of my pet peeves with C++ is the current way that you do random numbers in it. The old C library way of doing random numbers is really terrible technically. You know, and that's the thing with like srand. You know, let's do this, right? And cout rand modulus 10 or something like that. Like this is actually technically, this is bad, right? You don't get very random numbers as a result of this. The C++ way, however, of generating random numbers is much more technically sound. Like, you get better random numbers, but nobody can remember it. Everybody always goes to CPP reference and pulls up the code there. And even then, if you're a new programmer, you're probably going to do it wrong. So there is a experimental way of generating random numbers, which is how it should have been done from the beginning, where you just say, give me a random number between 100 and 999. Neat. That's how it should have been, in my opinion. But the current system is terrible. And if you want to have it be fixed, like a fixed seeded random number generator, so you get the same numbers every time, you just call reseed and pass in a seed value, and then you'll get the same. Yeah. Yep. So if you seed the random number generator, you'll get the same sequence of random numbers every time. Or if you don't, it will default to being fully random, which is exactly how it should be. So if you do this, you'll get random numbers every time, which is awesome. Or you can have it generate a fixed sequence of random numbers. Either way, the experimental random number system is really nice. It's just better than both the old way, the old C way, and the old C++ way. Anyway, so shuffle here is the more appropriate way of doing it, but in all honesty, random shuffle, which I think has even been removed from the standard, it essentially does the same thing using rand to shuffle the vector, maybe. I don't even think it's defined. But okay, so that's one thing you do. So you can take a range and it will shuffle everything in that range. Now, what if I did this? What if I said shuffle from begin +3 to the end? What elements is this going to shuffle? Which of my numbers up there are going to get randomly permuted? The first 3? Remember, the first value in the range is the start of the. It's the start of the area that's going to be affected. Yeah, so this is going to shuffle the back end, the 200, 100, and 20. Wrong one. Okay. So you see this got shuffled here. If we do it again, we get the same values every time because we are using rand. So if we do srand 0, then we will get different random shuffles. Maybe there we go. Yep. Okay, so this is shuffling the last 3. How do we shuffle the first 3? How do I write code that will randomly shuffle the first half of the deck, so to speak, the first half of the vector, and not the second half of the vector? For increased points, have your code work with any sized vector, not just the one we have here, but have it work with any sized vector. Have it randomly shuffle the top half and leave the bottom half untouched. See if you can figure out how to do that. Vector.in divided by 2 does not work. You would think it would work, but it doesn't. And the reason why it doesn't work is that it's not actually, a number that you can divide. When you do plus and minus, it'll move itself along the array, but division and multiply are not defined on it. So vector.end minus vector.size divided by 2, vector.begin +4. Yeah, that would kind of work. So if we just did vector.begin +3, this is actually, how many elements is this going to shuffle? Let me ask you guys that. Which elements is this shuffling here? If I say shuffle from vector.begin to vector.begin +3. which of the three numbers are getting shuffled? Remember the half-open code pattern. Remember that vector end points to one past the end. So if you shuffle from beginning to end, it actually shuffles up to 5, not up to 6. So if I say shuffle from begin to shuffle begin plus 3, which numbers are going to get shuffled? Ten 20, 10 20, 20 10. Yep. So, vector.begin is here. Vector.begin, not worried. Yeah. Plus 1 is this guy, plus 2 is this guy, plus 3 is this guy. So if you say vector.begin plus 3 as the ending part of the range, vector.begin plus 3, this is the end. And so it shuffles everybody before that. So these three guys here are going to get shuffled. The 10, the 20, and the negative 10. Okay. Because remember, even though vector.begin plus 3 is pointing here, the way the half-open code pattern works, when you have something like, 0 to 5, like that, the 5 is not included in the result. So if you say everybody from 0 to plus 3, then that's going to shuffle the first 3 elements in it. Okay? You don't need to really refer to vector.end at all. Now, in order to do this proper, to make it work with any size vector to do the first half, you'd say vector.begin plus vector.size divided by 2. And if you do that, this will shuffle the first half of the vector no matter how big or how small your vector is. Okay? This is the correct way of doing it. You cannot do vector.size divided by 2, unfortunately. Okay. So that's shuffle. What else can you do with it? Well, how about find? Okay. So let's just go back to the default range of beginning to end, and let's look for the number 10. So there is a function called find, and it returns an iterator. So it returns I need parentheses here. So it returns a pointer at I don't need you anymore. So it's either going to return a pointer to the element in the vector, or it will return vector.end if it's not found. So if iterator equals vector.end, we will see out, what are we looking for? Negative 10, not found. Else, see out, we can dereference it if we want. Okay. So negative 10 is found. If we search for negative 100, negative that's why you should not use magic numbers, right? Negative 100 not found. What about negative 1,000? Negative 1,000 not found. What about 20? 20 is found. Okay. So what you do is you call find. You pass in the range of values you want to search through. Normally it's beginning to end, but you could search through just the first half or just the second half. And then you pass in the value that you want to search for. And then it will return a iterator. And it will return an iterator, like if we're searching for negative 10 or whatever, it'll return an iterator pointing at it if it's found. If it is not found, then iterator is instead it the it team, the it squad, the it girl, the IT department, it is pointing at end instead. That's why end has to be off the edge of the vector. Because imagine if end was here, right? Then if you search for 420, how can you return a pointer indicating that 420 was not found? Because, you know, because the last spot could either mean not found or it would mean it was found here. So that's why end is in something called a sentinel of the multiverse. Okay. No, sorry, it's just called a sentinel. So this is called a sentinel node. This thing here is called a sentinel. And so it is a dummy node, a dummy value. You can't ever read or write to it, or you're not supposed to. But what that means is if you can't find something, then it returns that pointer, that iterator. And so if you ever get vector.end returned from a find like this, if you get vector.end, then it's not found. Okay. So lots of things, lots of neat things you can do with vectors. Shuffle them, sort them, use accumulate to add them all up. Delete from the end of them. So you say vector.pop back. This will delete the second 20. It's going to delete that guy there. So when you do pop back, it deletes the end of the vector. Is there a pop front? Nope. Not with the vector. If you try doing a pop front, doesn't work. Doesn't work. Only pop back. Vectors can read and write to the back only in such a way. It can only grow and shrink the vector at the end. If you want to do it off the front, there is something called a deque. No need to use the sad emoji, Garza. I'm going to show you pop front now exists. A deque is just like a vector, except you can call push front and pop front. You can add things to the beginning, you can delete things off the beginning. So if I do this, then the 10's going to go away. All right. So the beginning of the vector here is 10. So if we pop front, gone. Okay. So a lot of students ask, well, why don't we just use deques all the time then? And the answer is they're slower than a vector. So unless you need pop front specifically, like unless you need that functionality to push and pop off the beginning, use a vector. Because vectors, when I benchmarked it on our server, they're about 30% faster, I think. So there's no reason to sacrifice performance for no reason, you know, like unless you are trying to delete off the front, in which case use a deque by all means. But if you don't need that functionality, then it's best to just stick with a vector. Okay, so that is our like CSI 40 overview of vectors. You can search them, you can shuffle them, you can delete things from them, you can insert things into them, sort them, lots of things. And now that you know about it, you don't have to write that code yourself. You do not have to write merge sort yourself. You just call sort on the vector. And if you want to select a portion of it that you want to sort, like if you want to just sort the middle third or something like that, then you can do that little bit of algebra with vector.begin plus, it'd be vector.begin plus, like, let me just show you what it looks like. Like if you want to sort the middle third, you would say sort from vector.begin plus vector.size divided by 3 to vector.begin plus 2 times vector.size divided by 3, something like that, I think. So sort from 1/3 to 2/3. Yeah, so that should sort the -10 and the 200, which is already sorted. And so you can see that 10, negative 200 becomes negative 210. So you can use these pairs of iterators to select a region, a range, as we call it. You can select a range that all of these standard library functions work in. You can shuffle the top 10 cards. You can shuffle the bottom 10 cards. You can sort the middle third. And there's a lot of functions like that out there. But I would say those are really the important ones. So you guys understand this? If you understand this, you're good. In addition to the basic stuff, like cout vector.at 0, .at, you guys all know. That'll give you 10, of course. Vector.size, you all know that's how many elements are in it. This is going to print out 10. And let's turn this guy back into a vector. There we go. All right. So you guys all know vector.at. That gives you element 0, 10. Vector.size, that'll tell you how many elements are in it, 6. Vector.front is the same as vector.0. Vector.back is the same as vector.at, vector.size minus 1. The last element. So vector.back is going to print 20. It's the same thing as that, just a lot less typing. See, we got 20 both ways here. And that is, I think, a pretty good overview of vectors. So I'll stop the recording now.